Welcome back to the Bini Game Project series. In this project, I am building my own custom gaming device from scratch, combining electronics, programming, and 3D design. In part 1, I focused on building the core gaming system. I programmed the software using AI, tested the controls, and created the first electronics prototype to make the device functional. Now in part 2, I will continue improving the project by designing the enclosure in Fusion 360 and upgrading some of the electronic components to make the system cleaner, stronger, and more practical. This part of the project is focused more on product design and hardware improvement, turning the prototype into something that looks and feels like a real handheld gaming device. Here's the full enclosure design process inside Fusion 360, where I worked on the overall shape, internal component placement, and structural design of the device. After completing the enclosure design, I realized there was a major problem with the Arduino Nano. The board was too thick because of the long header pins, and it became very difficult to fit properly inside the enclosure, together with the buttons and other components. If I continued using the Arduino Nano, the device would become much larger and thicker than I originally planned. So instead of changing the enclosure design, I decided to redesign the electronics completely and create my own custom controller board. For this custom controller design, I used a Type-C female breakout board for power and communication, a 28-pin IC socket for mounting the microcontroller, a low-profile 8 MHz crystal oscillator, 6 black 2-pin push buttons for the controls, a 0.9 6-inch 128 by 32 OLED display, a double-sided 5 by 7 cm prototype donut board for soldering the circuit, a small two-way slide switch for power control, a PCB-mounted 5-volt buzzer for sound output, and the main controller, the ATmega 328P-PU microcontroller chip. This new approach allowed me to create a much cleaner, thinner, and more compact gaming device design. After finalizing the custom electronics design, I soldered all the components onto the prototype PCB board, including the buttons, OLED display, buzzer, power switch, Type-C breakout board, and the IC socket for the microcontroller. Once the hardware assembly was complete, I programmed the ATmega 328P microcontroller using an Arduino Uno. Instead of permanently using the full Arduino inside the device, I used it only as a temporary programmer for the ATmega chip. First, I uploaded the Arduino bootloader and game code to the ATmega 328P. Then, after the programming process was complete, I removed the microcontroller from the Arduino setup and installed it directly into my custom controller board using the 28-pin IC socket. This approach made the project much smaller, cheaper, and easier to integrate into the enclosure because I only needed the main microcontroller instead of the entire Arduino board with large headers and extra components. Using the standalone ATmega also gave me more control over the hardware layout and allowed the internal design to become cleaner and more compact. After completing the assembly and programming process, it was time to test the electronics. Here's the first full hardware test of the custom gaming system, where I checked the buttons, display, sound output, and overall functionality of the device. The system powered on successfully, the controls responded correctly, and the game was fully playable on the custom-built electronics. Now that the improved electronic system is fully working, the next step is to redesign the enclosure in Fusion 360 to match the new custom controller board. This updated design is important because the internal layout has completely changed. The Arduino Uno is no longer part of the system, and everything is now built around the ATmega 328P-based custom PCB, which allows for a much thinner and more compact structure. In this next section, I will adjust the enclosure dimensions, reposition the internal mounts, and redesign the button layout to perfectly fit the new electronics. This will also help improve usability, reduce wasted space, and make the device feel more like a real handheld gaming console. Let's see how I upgrade the design in Fusion 360. I have now completed the final enclosure design and sent it for 3D printing using PLA material through an online manufacturing service. After a few days of waiting, the package finally arrived. The box included all the printed enclosure parts, carefully packed and protected to prevent any damage during shipping. First, I opened the package and inspected each part one by one. The surface quality was clean, the dimensions matched the Fusion 360 design, and all the screw holes and internal mounts looked correctly printed. This was important because even a small error in size could affect the entire assembly. Before starting the assembly, I prepared all the electronic components and laid them out in order. The custom PCB with the ATM EGA 328P microcontroller, the OLED display, push buttons, buzzer, power switch, and Type-C power input were all ready. To improve the final build quality and protect the display, I added a transparent plastic sheet that I cut into shape manually. This acts like a protective cover or lens for the OLED screen. It helps prevent dust, scratches, and direct contact with the display while still keeping the visibility clear. Then I started the assembly process. I carefully aligned the internal structure of the enclosure with the electronic components. Each part had its own designed position, so everything could fit tightly without wasting space. The buttons were placed precisely into their slots, the OLED display was aligned with the front window, and the PCB was positioned in the center mounting area. Once everything was aligned, I started fixing the structure using M26mm screws. I slowly tightened each screw step by step to make sure the frame stayed balanced and nothing shifted out of place. The screws helped lock the top and bottom parts of the enclosure together, making the device feel solid and stable. During assembly, I also double-checked the wiring and connections to ensure there were no loose joints or misaligned pins. The compact design made cable management very important, so everything was routed carefully inside the limited space. After fully tightening the enclosure, I tested the system again. The device powered on correctly, the OLED display worked, the buttons responded properly, and the buzzer and switch functioned as expected. At this stage, the project is no longer just a prototype on a desk. It has become a fully assembled handheld gaming device, combining custom electronics, programming, and 3D printed mechanical design into one complete system. This is the final integrated version of the Bini game project.